everyone, welcome back to my channel Upskill Space. In this series, I'm going to talk about today the third part of the sequence where I discuss Python Pandas interview sample questions. And of course, these are the questions that you're likely going to face for data scientist or data analyst position. So let's right away jump to the question that I'm going to take up for the day and see how that can be solved very easily using Pandas framework. So the question for the day is to find the weighted average sales by line of business. Now, in order to understand this question, you must be familiar with the data set. So please see and know about the data set that I have described in the first video of the sequence. Get familiar with the data set, what each of the variable means, and how they can be connected with the real-time business. Once you'll be comfortable with elaborating what the data set is all about, you'll be easily able to understand this question requirement as well. So if you have already understood the data set and if you have followed me with this question, let's see what is being expected. So when you say weighted average sales by a line of business, that basically means if you see we have different line of business. If you could follow my cursor, yeah, so we have a different line of business, right? Some different categories. And if you see there can be, it's possible one particular line of business repeat multiple times. And corresponding to every row, we have some cell values. Now the question here is, I'm interested to not just compute the average of the total cells, but weighted average of the total cells. What do you mean by weighted average? So weighted average is very frequently nowadays used at industry level. Statistically, if you talk about it, weighted averages are good to take care of the overlap or outliers data. So weighted average is considered to be more stable, robust parameter to describe the central or feature of a data set rather than just the average, given that if you know there are frequency imbalancing happening within your data set. So in this case, I'm not just going to compute the average of the cells, but I'm also going to compute the weighted average of the cells. And to understand it simply, listen out to me this carefully, where I'm going to explain that with an example. So let's say you have two distinct line of business. Let's call here right now LB1 and LB2. In our real data set, we have, I think, uh, four different line of business. So that could be metas, FB channel, and so on. So just to give you an idea, this line of business in simple means the mode of operation. For example, website of a company can be one line of business, app is another line of business, selling through a third party platform would be the third line of business. So companies like to understand through which channel they are receiving the maximum orders, so that in future they can plan well to maybe invest on that particular channel, and also eradicate or just reduce the investment on the channels that's maybe taking more maintenance expense compared to the income. So assuming we have LB1 and LB2 as a line of business and the corresponding number of records for each of this line of business, let's call that N1 and N2. What that means, let's say we have N1 records, total records for LB1, and then N2 total records for LB2. Right, so we know now distinct line of business and we know number of records corresponding to those line of business. The next question is then, so what about cells? Because to compute the weighted cell of, you also need to know the cell in each of these channels. So if you see, we have an weighted cell formula that's given here, uh, and that goes this way. Weighted cell is defined as frequency of LB1 into average or total of the cells. So if mu1 and mu2, here are the mu1 and mu2, if mu1 and mu2 are the total cells for each of this channel lb1 and lb2, then what is weighted average? That is just n1 times mu1 plus n2 times mu2 divide by total number of records. So we are dividing, multiplying individual cells with the frequency first, and then we are adding them together, and then finally dividing with the total number of records we have. So for example, let's say if you have n1 equal to initially 10 and n2 equal to maybe 50, and then you have mu1 equal to let's call that 500, and then mu2 equal to let's call that mu2 is equal to 200. Yeah, that's good. So if you see for and n1, yeah, n1 corresponds to lb1. So if you see we have I mean overall, just if you see overall, the total cells in first line of business is relatively double of, more than double of that of second one. However, if you see in terms of frequency, n1 has lesser, I mean it's 5 times lesser frequency than n2. So that's why if you see there's an imbalance in terms of frequency. So to take care of this frequency repetition, in order to compute the center value, the weighted averages or weighted sums are being computed, which makes more robust parameter statistically to understand your data much better. So now in this case, if you have to compute the weighted cell, what that would be? That will be 500 times 10 plus 200 times 50 divide by 100, sorry, 10 plus 50, and that should be your weighted average. So now, although just on the basis of mu1 and mu2, 500 was more than 200, 2 times greater than 200. That means, in other way, if you have to say it, lb1 cell was almost 3 times of that of lb2 cells. That's what we were telling, but we realized that's not true, because we're just less than 5 percentage of the total number of contribution of lb1 in terms of frequency. That means the actual contribution is 500 into 10. It's like similar to like computing the probability of a percentage contributed contribution of lb1. So now this will give you just 5,000, and the second component will go, that's 1,000. You see, that's more now when you compute with respect to frequency, and divide by 60. So that will be your basically weighted average. Now this is quite simple to do when you have just a scalar numbers like this, right? You have n1 given, n2 given, mu1 given, mu2 given, and you have a formula right away here. You just substitute them, do it. Very easy to do. But what if you have this to be computed from the data first, and of course a 2D data in form of a data frame, and then you have to compute it? Are you going to first individually find out n1 and then n2 and then n3 and mu1, mu2 and so on? Like in this case, if you see, are you going to manually first compute n1? What do you mean by manually? Separately take all your in this a metas line of business, count its frequency stored as n1, then take the cells of metas and total cells and store it as mu2, and then do it for again the fb channel, similar thing. You know, you can do, but again it's tedious. Right now we just have 4 distinct channels, so maybe 4 into 2, 8 variables you can create and you can store. But is that practical? What if you have 1,000 channels line of business basically? In that case, are you going to create 2,000 variables, store them, then go ahead and write this formula and substitute and do it? Not at all. Nobody would like to do that, given the better approach or simplified approach pandas suggest for you, and specifically DataFrame. And honestly, I'm telling you, this is a question that was asked with me in an interview. So this is not something that may looks to be very simple for you and you can discard. No. Most of the interviewers like to ask this question for the very reason that it demands you to think about it. It is very simple. If you know the answer, it's very simple to do. Just 2 lines or 3 lines, it should be done. But thinking or arriving to that conclusion, given that you know the powerful features of the pandas and data frame specifically, makes your solution distinct and different from others and makes you a better candidate over others. So that's what I'm going to show you in this particular video, where I can tell you, look, whenever this sort of question comes, but again, you just do not write that 3 lines of code. Simultaneously speak about it. Explain the interviewer why are you going with this approach rather than creating these individual variables and then substituting to this formula what you see here, right? So that is what you have to do. And if you can narrate that or you can convince that to the interviewer, I'm sure the interviewer is going to be very much convinced. So in this further, I'm just going to right away do that with along with the explanation. Do watch it. All right, let's jump onto computing n1, n2, mu1, mu2. And once we'll have them, then what we are going to do first, we are going to perform the top part, numerator component, and then we are going to do the denominator component and divide by the denominator. Now and if you see n1 n2, these are going to be quite same on the numerator and the denominator parts. These are not going to change. So now the question is, how should I do? Okay, here is what you can do. If you can, now given that you have many line of business, you have many line of businesses, what you should do, you should think in terms of group level or line of business level, computation of sum. You know, group by method in pandas that can help you to compute for many groups the total of some value or the aggregation of some values in just with one line of code. So that's what I'm going to do. I'm going to first compute sum, that will be mu1, mu2, mu3, mu4, and so on, given how many distinct line of business we have. And then later I'm going to compute uh, their frequencies, which is n1, n2, and so up to n. Okay, so there it goes. So what I'm going to do is, that's my data, the data, right? This data right now for us, the important columns are line of business and total sales for this particular problem. So I'm not focusing too much on the other columns, but again, for next problem, we may take them up, all right? So df dot group by, on what do you want to compute the group aggregate level sum? I want to do it on line of business level. There it is. So group by this, on which column do you want to do this computation? So I want to do it on cells, total cells column. And what aggregation? So right now, first I'm computing mu1, mu2. So that's what I'm doing it. Mu1, mu2. In fact, there are 4 columns. Let me first show you how many distinct line of business we have. So there it goes. Line of business dot values count. If you do, that should give you, so okay, yes, we have 3 distinct of them. You look at here, okay? So metas has 295 occurrences in our data set. That's the highest, followed by papri, which is 192. And if you see fb channel, there's a single occurrence, right? Let's also see their individual sum of values. How can I do that? So I'm going to do this total. Okay, so that won't come until you do group by. Okay, let's do in the next line. Let's comment that out. So here it goes, total cell sum, right? That should give me line of business. Now this is again interesting. Okay, so if you see, the maximum sum is again here for metas, which makes sense, fine. In this case, it's going in direct proportion scenario, mu1 and n1, but it may not be always true given the data you have. And specifically, I'm sure the data that you'll get in interview will have some this sort of imbalance created. So FB channel has just a total of 14.98 cells, and Metas has some 5,119.257, and Papri has 1,930.750. Right? So now what we have to do is basically multiply them together first. So first we are going to compute the upper one, the numerator components. Okay, numerator is nothing but, if you see, it's a sum of the products. So once we'll have, you can imagine this way. Okay, so my solutioning is going to be around this way. Give me a second. So what is my idea? My idea is, what if I, for every line of business, I call that LOB. Okay, for every line of business, what if I have one column representing frequency or N? Okay, and the second column representing total sum, I call that mu M U. Okay, um, I hope you can make out. It's difficult. Now let's say you have first line of business, which is Metas, Mexas, and the count is 295, and the sum is how much? 5119 point, and so on. And then second is Papri, and the count is 192, and the sum is 1930 dot so on. And the last one is FB channel, I call it FBC, and the count is 1, and the total sum is 14.98, right? What if I get this table generated? What if I get this table generated? And then wouldn't it be easier for me to compute the numerator part? Numerator part is nothing but individual group level product of N and mu, right? So if I could, now, so my idea is now to create one more column, given that I have this informations in the same data frame. All I'm going to do is create a new column here that I call new column. And then I'm just going to multiply these two together, these two together, these two together. So what this will give me? This will give me mu1 plus n1, mu2 plus n2, mu3, sorry, not plus, it's multiply into n3. So I'll have all the numerator already designed here. Okay. And I already have n1, n2, n3, n1, n2, n3. So now what I'll be left with? All I have to do is first sum them up. If you see, once you have mu1 product of this individual component, you just have to sum them up. And when you have individual numbers n1, n2, n3, that also you have to sum them up. So just sum them up. So how can you sum that in one line in a data frame? Yes, again you have to just say sum of n column and sum of the new column that you create, what I'll be calling weighted factor weighted sum. And then once I'll have this sum, I call it value 1, and this sum value 2. All I have to do is value 1 divided by value 2. And this all you can do with just vector operations without literally creating many variables, if you are following these steps strictly on a data frame. And that's why data frame is very, very popular for vector operations. I hope you got the complete picture of it, what we are trying to achieve. Now let's achieve that out. So I got the sum, right? I'm going to store it as, or if you want, you can reset it to even see it much better. Basically, I'm converting it to a data frame from a series. And if you see, that's my data frame. If you want, if you do not like this total sums, I mean, if you really want to rename it to another variables, that also you can do, rename underscore columns. And then you can go ahead, rename underscore name. It's rename. And then you give columns. I call it total cells. Yeah. So I just call it T cells or small letter T cells, up to you. Okay, I'll tell you why that's it. Anyway, come to that. We don't have to rename. Okay. So I got a data frame. I call it a temp data frame. Okay. So I'm just interested in this result at this point of time. I call it temp data frame, which or I call sum data frame, up to you, sum data frame. This will have all the sums. So there it is. For every channels, I have the total cells now. Now the same thing I have to do to compute basically mu1 and n1 and n2, which will represent your frequency. So I call n1, n2, and n3 in fact, n2 and n3. Let's call that here mu3 2. Right. So it's the code is going to be quite similar. Its only thing is instead of sum operation, you are going to do count. That's all. If you do count and then I call it count data frame. Now, what is benefit of doing it in a data frame form? You are not literally doing for every distinct, you are not writing code for every distinct line of business. You are doing it at a group or vector level, or you're broadcasting your logic to the every row. So that's the benefit of working with the data frames. And if you see, that's my count, right? If you notice, we had the individual counts, but it was in a separate object. Right now I have as a data frame, that was a series, this is a data frame, right? So if you see, I have a one data frame where for every line of business I have total cells. I have another data frame where for every line of business I have not total cells. I don't want total cells here. It requires renaming. So rename, and then you have to say columns, which columns you want to rename. And I want to rename total cells as a frequency. This short form is frequency. And that gives me renamed data frame. Now I have data frame 1. I call this data frame 1. And I have data frame 2. The good thing is, of course, they are computed separately, but the good thing is we have for every distinct uh, line of business. So right now we have just three line of businesses, but even if you have 1,000 line of businesses, you can do that with just these two lines of code. You see, hardly there are two lines. I mean, the last line is just for display purpose. You can skip them. This is line 1 coding, this is line 2 coding, and now the third part is you just have to combine these two data frames. So I'm going ahead and combining them. You know what, if you really do not want to compute these two separately, you can also do them in one line of code. I will just tell you how to do that in a next video, but you can also do in one line of code. Right now I'm going ahead and then I am combining above two data frames. You see, can I do that? So, well, there are multiple ways you can combine two data frames. It's all up to you. I will follow here a very simple of merge approach. Merge are always easier to do. What I'm going to do is sum data frame dot merge uh, and then count data frame. Okay, on what am I going to do there? The mergings, I am going to do the merging on nothing but their index, left index and right index. Right, there it is. So that's line of business. Up to you. I mean, it's if you want, you can also do on. I think here in this case it's much better to do it on. Very simple. If you don't know about merge, please read about it, how it works. In fact, I have a video on this. If you can go through, it will be much clear for you. Otherwise, to merge two data frames or three data frames or n data frames, again, you can do in hardly one line of code. And you see, I got it. I have a single data frame now, which I call it weight df. I have a single data frame that will have now that has now all the complete information as a 2D form that I was looking. Right now, all I have to do is linear operation to compute my weighted average. And what is that? Given this data frame I got, which is weight underscore df, I'm going to now first compute my sum of the product of the individual frequency and average total cells. Okay, so that I call, and I want in the same data frame. Okay, after multiplying them, basically I want them here as a new column. I do not want to store to a different variable. That's how your life will be easy. So you create a new column here. You can call it anything you want, and that individual row values should be nothing but product of these two. And that's what I'm going. So what I'm doing is uh, weight underscore df dot total cells into, you see, it's called vector operation. You are writing the code as if you are dealing with two different scalar variables, but you are actually dealing with many rows at a time. Df dot frequency. Have a look. I got the product, right? You multiply 295 or roughly 300. That goes 300 into 5,000 should be roughly 15,000, and that's what we got it here, right? And but I have to store it. I cannot leave it. I need in the same data frame for the reason because my data frame I also need individual n1, n2, n3. That's the reason I'm going ahead and I'm saying, so weighted sum. I call it weighted sum as a new variable to my data frame. Now after running this code again, you see I have a new column here called weighted sum. Now, what is my next step? All I have to do is sum them up, all the elements of weighted sum all the elements of frequency, and then divide weighted sum by total frequency, total weighted sum by total weighted frequency. So to do that, what you can do it very simple. Again, you can do it in the same line, dot group by. I'm going to sum them up, right? So, now the question is, do you want to separately sum them up? Up to you. Okay, so it's going to be very easy. I don't need any levels. I'm going to directly sum them up. Dot sum. See, that's my total sum. Divide by frequency sum, right? So again, you can do that. Df dot wd dot frequency dot sum, and that's my weighted sum. The answer we were looking for. That's the weighted sum. In fact, it's called weighted average, not sum. Why it's called average? Because you are multiplying the total sum. This is weighted sum. This is weighted sum. It's called average because you are dividing by the total number of count. So now it becomes weighted average. And this is the weighted average cells in this problem, given the different line of business we had. And here I stop my video. I hope you understood this one. If you did not rewatch the video, as I said you before, this sort of questions are asked in real time. It was asked in my last interview, and I knew the solution, but I projected as if I do not know. But the important thing is, you see, the solution is pretty easy, just 3 to 4 lines of code. This display components are not even required, but I'm writing it here just for your convenience to look through every intermediate results. But this goes very important for you to, I mean, whenever the interviewer asks you this question, they know the solution is in just 1 to 2 lines. But along with this solution approaching, how do you explain your solution? How do you narrate through? How do you explain when you are thinking of the solution? That's what they look for. So try to, the way I explained it with a reasoning, try to explain the same way along with writing the code, and that will take you hardly 30 minutes. And if you could do it, it's guaranteed you will get selected for the given interviews. I hope you liked it, and till my next video, have a happy learning.